Our third speaker is Amelie Laute. Amelie is from Germany. She just finished her Bachelor of Biology at the Kiel University and is starting her Master's in Biology Oceanography this October. She has been working with WhaleWise since 2019 and is focusing on the bioacoustics part of the WhaleWise project. Amelie will be talking about impact of COVID on both noise and whale calling behavior.
Okay, hi everyone, welcome also from my side. It's very exciting and I feel very honored talking here to you today about the bioacoustics part of our project. I want to start by looking at this picture. You can see a humpback whale going for a dive. Here in Skelfandi Bay, to most of you this is going to be a very familiar scene. And I was wondering what that whale might be experiencing when he dives down there and what he might be hearing. For example, he might be hearing this whale watching vessel or any other anthropogenic sources of sound in the ocean. Or he might be hearing the weather, the wind, the rain, the waves, all these geophysical sources of sound. Or he might be hearing his companions, the other whales in the bay, and it's really important for him to communicate. So I was investigating the acoustic habitat of the humpback whales here in our beautiful Skelfandi Bay in Iceland, and we were kind of lucky that COVID happened. Compared to Alyssa, she was not lucky. We were kind of lucky because we could look at the impact of a season with very little human impact compared to with a lot of human activities. I will first show you the kind of data that we collected. So obviously we needed acoustic recordings. So we had a hydrophone in the water last year close to the rock Fiskesker. And we had an additional hydrophone in the water that we got data from our colleague Adam Smith in 2018, close to the island Laute. Most of you will know those locations anyway. And we could compare 2018 before COVID with 2020 during COVID and had 2 months to compare, middle of June till middle of August. For those of you who are less familiar with bioacoustics, this is how a hydrophone looks like. It's an underwater microphone. You deploy it at the bottom of the ocean at about 50-meter depth in this case, and it just stays in there for several months, and when you want to get it back up, you have this really nice device called an acoustic release. So you just go there in the end with your boat, you send a signal, the device opens its hook and everything comes back to the surface, and then we were really happy when we could retrieve our data and then you can look at it on the computer. So that's the basic data that we needed. But we also collected visual observations. So on the western shore, 2 hours by foot north of Neustavik, we were camping for a few days and we had a theodolite, and we were basically counting the whales and marking their positions within half-hour surveys so that we would know for certain times if and if yes, how many whales were present and where. And the third type of data that we got is AIS data, so basically GPS location of the vessels in the area, and we got that from the local coast guards, both for whale watching and for non-whale watching vessels. And with all that data, we could start to answer some questions. And the basic question that I needed to know was there actually a difference between the seasons and the vessel traffic? And if you look at the whale watching, that's a definite yes. And you can see that this is hourly average position of the vessels, and you can tell how much denser they are in 2018 compared to 2020. In fact, we had on average 42 whale watching trips in 2018, while only 13, so only a third of the number in trips in 2020 on average. So that was true for whale watching, while for non-whale watching, it was much less obvious. There was no really significant trend between the 2 years. So indeed, we had a decrease in vessel traffic, but very dominantly only in whale watching, which makes sense because obviously COVID didn't change the fishermen's activity a lot. So the next question I was really interested in is how does it actually sound like in this bay? So for that, we plot sound as an image called a long-term spectral average. And you basically see from left to right is from middle of June till middle of August. So it's the full season in 2018. The y-axis is the frequency, and the color is the loudness. And you can tell that there's like patches of bright, that's very loud, and patches of darker blue, that's fairly quiet. And I wanted to see, where do those patterns come from? What are the dominant sources of noise here in the bay? And if you correlate that, or if you overlap that with environmental drivers like wind speed, precipitation, surge, you can clearly see that they overlap with these large patches. So geophysical sources of sound were a very dominant driver of noise in the bay. And that's exciting news, because in a lot of places around the world, anthropogenic noise is that loud that you have a hard time hearing those natural forces. So that was exciting to see that. But you might have also recognized there is another pattern, those little boxes on the bottom, and I started counting them, and they're exactly 61, which is the number of days that I analyzed, so that was cool to see. And when you look more closely into the days themselves, it was very obvious that this noise is from vessels. So while geophysical sources of sound were dominant driver, vessels were also shaping, or are also shaping, the noise in this bay. Now, if you compare that to 2020, you can still see that environmental drivers are very important, but the vessel pattern is less pronounced. You can still see it, but it's less, which makes sense, right? If there are less vessels, you have less of an impact of them on the daily pattern. Now I'm just going to show you a few examples, and this is when we will try to make the speaker work. Just for those of you who haven't heard that kind of recording before, this is how a vessel would sound like underwater. It's a few kilometers away. And it can get much, much louder if the vessel is coming closer. But this is a very regular sound that we heard. And this is how a humpback whale sounds like. It's a very common call. It's called the whoop call. And it's a very regularly heard call. And it always makes me really happy finding it. And the humpback whale calls are quite various. They don't only produce these whoop calls, they produce a whole range of calls. And just to give you another example, they also produce these kind of calls. You could tell at the end there was another whoop call. So we were quite excited to see that we can even hear the whales, because humpback whales are famous for their song, but that's only produced in the breeding grounds and only by the males, or predominantly in the breeding grounds, while these calls are produced all around the world and by both sexes, but they're a lot quieter. So in a lot of places of the world, you can't hear them because the background noise is just too loud. So it was already a result by itself that we could hear these calls so well. Even though I know that other people have listened to the bay here before and have already heard the whales, still it was really exciting to find so many of them. They were present in most of the data. Now, the question that came after that was finding out if the humpback whale detection, so the probability to hear a humpback whale, would change if vessels are present. Is that dependent on each other? And for that, first, let's look at the daily distribution on how probable it was to hear a vessel. So in dark green, which kind of looks black there, you have 2018, light green is 2020. And obviously, we see that in 2018, it was more likely to hear a vessel over the course of the day. So that's the hours of the day on the bottom. Then in 2020, which makes sense if there were more vessels. And also you see this clear diurnal pattern that during the day, it's more likely to hear a vessel. I guess that makes a lot of sense. On the other hand, if we look at humpback whales, we also see a clear trend between the years. We heard humpback whales a lot more in 2020. And you can also see a diurnal pattern that it is less likely to hear them during the day. Now, you could easily get to the conclusion that one is because of the other, that because there are so many vessels during the day, we hear less humpback whales. And that could be true, but it could also just be a natural trend. Maybe humpback whales are just calling more at night. Maybe they're feeding more, and that's because they're calling more, or any other reason. So to account for that, we built a model, and now this is getting a little bit more statistical again. So we built a model where we included hour as a random effect to account for time of the day. And if you look at that, you see that 2020, again, had just a lot more, the probability of detecting a whale was a lot higher. But also you see in both years independently that the more vessels you would have in the vicinity, that the less likely it is to hear a whale. Now that's interesting by itself, but that doesn't answer the question if the whale is changing its behavior. It could be that they indeed call less when there are boats, but it could also be that they leave the area when there are boats around, or that we could just hear them less good if there are boats around, just because of the noise around. So to look for that, we included our visual observations. This is where they become important, because for those times, we could decide only to include the times where we knew whales are present. So we knew how many whales were in the area and we knew they didn't leave. And also we only included the times or the whales that were within 3 kilometers of our hydrophone. So we knew, even if there's a vessel present from other studies, we know that this is a range where you would very likely still be able to hear the whale. So masking, being covered up by the noise of the vessel, wasn't such a problem anymore. So it was likely that if we still see a change in behavior, or a change in probability of call detection, that is a change in behavior. And again, we built a model for that. And that is something very obvious. If you increase the number of whales within 3 kilometers, the probability to hear a call is rising. That makes sense, right? If you have lots of whales, it's more likely that one of them is calling. But also, interestingly, if vessels are absent, it's much more likely to hear a whale than if vessels were present. And we tried to include noise in that model and realized it didn't matter. It doesn't matter how loud it is, that doesn't change the probability, or that doesn't drive the probability. It just matters if the vessel is present or absent. So you can get to the conclusion that it's very likely that the humpback whales indeed change their vocal behavior and call less in the presence of the vessels. Okay, what does that mean for us here in the bay? Well, on the one hand, it is good news because we found in our long-term spectral averages, and I forgot to point that out in detail, but it is very quiet in our bay. And it is in total much quieter than in a lot of places of the world. Like I said, we can hear the humpback whales really well, and if we can hear them well, that's also likely that they can hear each other really well. And that's really good news for the whales. On the other hand, we also see that they might have a change in behavior around the vessels, and that means we need to be really careful on our impact. And obviously also acoustic reaction might not be the only reaction. They could also behave acoustically independent of the vessels and show other signs of disturbance. So it's really important to keep that in mind, that this is just a very partial look on the whole topic if the vessels might be disturbing the whales. So to further look into that and to find out if that indeed has some negative implications for the whales, we have another hydrophone in the water, which is just on the opposite side of the bay again, where we had our hydrophone in 2020 as well. And then we can look at before COVID, during COVID, and now kind of when everything is increasing again, but without the slight difference in location. But in our project in general, we also collect a lot of behavioral data from the whale watching vessels, and we collect our blow samples where we look at cortisol levels, so stress levels of the whales. So it is much more, it needs to be more inclusive than only the acoustics to really see if that matters for the whales and what long-term consequences that could have. But that will all be topics for many, many more talks and can't be covered today. So for now, I would like to thank you for your attention, and I would also like to thank all the collaborators. This is just a few of them, obviously the WhaleWise team and my supervisor, Michelle Frenay from the Cornell University. Without her, that would have been very difficult to do. And also the University of Iceland for providing resources and knowledge, and all the other people that have collaborated, and the Husavik community for providing this beautiful place and joining in the effort. So thank you all. And now I'm happy to take questions if you want. I'll be able to see if there are questions in that corner. It's really bright. You have one? Yeah, go ahead.
Do you only have this one microphone in Skjálfandi Bay at the moment, or are you doing a bigger research?
The question is if there's only one hydrophone in the bay at the moment. And yes, we only, from our, well, technically there are two, but they're both attached to one buoy and one anchor. That is just because we're trying out a different kind of hydrophone called an audio moth, but that's a separate project, which is like the small hydrophone that only costs $100, which is really exciting. And we attach that to the really good hydrophone to see if the quality is very different, but it's only at one location for now, just because it's really difficult affording more than one instrument. But for now, we only have one hydrophone. There was the blue whale survey, and they had hydrophones at separate places when they were doing their surveys, but not long-termly. And as far as I'm aware, no other project currently has a hydrophone deployed. I don't know, Marianne would know more about that. All right.
Yeah, what do you think the meaning is of the different vocalizations that the humpback makes on the feeding grounds, and what could the ecological implications be if they're actually disturbed by the boats?
Okay, the question is what the different humpback whale calls mean on the feeding grounds, or what we could think that they mean, and what a disturbance could ecologically mean for the whales. Most of it is completely unknown. There is one call that the purpose is very well known. That is in Alaska. There's a call that's called the feeding call, and it's used for feeding. It's in the hearing peak frequency of herring, and it's probably used to manipulate the herring, so for that call, and also to cooperatively feed. That one is very well understood, but apart from that, it is very much not researched a lot. My supervisor is actually doing a lot of work on that in Alaska, and she proposes that the whoop call, which is, if you look all around the world, there are like 5-6 places where humpback calls are even only studied, because as I said, in most places you can't hear them very well. But everywhere you hear this whoop call, it seems to be the fundamental call, and even the other calls sometimes sound like they come from the whoop call, because it's the same call just without the whoop at the end and things like that. So the theory is that this whoop call might be a contact call, that they just produce to say, hi, I'm here, and maybe even, hi, I am this and that whale, and I'm here, and possibly, for example, also to spread out so that they wouldn't be too close together, for example, so that they can feed effectively on the food. But that is very, very preliminary, and they're doing playback experiments at the moment, or have done playback experiments. There's a documentary on Apple TV Plus called Fathom. We've screened it a few days ago in the museum, and that talks a lot about that. But for all the other calls, we have no idea. And because we have no idea, we also have no idea what the ecological consequences would be. But seeing how frequently they vocalize, it's very likely that it is important for them to vocalize, obviously, otherwise they wouldn't spend the energy doing it. So it's really important that we make sure, while we don't understand it yet, that we make sure that they can still communicate, and at the same time try to understand the meaning. Thanks for the question.